What's up, everybody? This is Eddie with Flex Machine Tools, and I'm hanging out by our latest and greatest project, the FlexJet water jet machine, and also hanging out with the man behind it, the mastermind, if you will, our good friend Chris. So, hey, we got a lot of questions that our customers and prospects are asking, and we thought, who better to give us all the information that we need to know than yourself? So, for everybody who's watching this, give us a quick insight on who you are, what you're doing here, and then diving into this, and then we'll ask you a couple more questions.
All right. My name is Chris Ashworth. I've been involved in water jets and water jet cutting for the last 30 years, mostly as an independent integrator working on many machines besides the water jets. But you know, most of it's been doing the exotic things more specific to customers' needs, being on site and working with the end users directly. But over that time, I've developed a lot of ideas and things that I think are a little bit better way to go, and this 5-axis head that you see is a part of that scenario. Sure. So we'll get into some more details on what that means and what the advantages are maybe to our head versus the competitor's head.
Yeah, no, this is great. There are so many cool things happening, and with this still being a newer project, you bring an infinite amount of experience that really helps accelerate that process of disruption. So when it comes down to it, one thing that we really are bragging about, and one of the bigger features, is that taperless cutting with a 5-axis head.
Right.
I get so many people who would say, oh, okay, hold on, explain that.
Okay.
So what is that? Tell us
now,
about
well, taperless cutting it's really just setting the angle of the head so that you get a vertical wall on the outside cut. So you don't have, like water, when it's cutting down through it, it wants to blow out, you know, depending on how thick it is. The thicker it gets, the bigger the kerf is at the bottom. I mean, earlier today we were doing some pipe, cutting both sides of the pipe at the same time, and the kerf on the bottom was much bigger than the top. So if you tilt the head to give you a vertical wall on the side, it gives you basically your part is taperless. Now the term taperless, there's other terms used in the industry. As far as, you know, the competitors, they call it each of us call it something different, but it all comes down to the same thing. So on our head, you know, you set the angle of whatever your taper is, and then we turn that into tangential following, which becomes the infinite C becomes part of that. You don't have to worry about winding and unwinding the head like you do with a typical rotary tilt head that has limitations on the travel, like how many revolutions before you have to unwind it. We can infinitely run this thing all the way up to like 60 RPM, you know, forever. There's no limits to what we can do there. One of the other things is we're not limited based on the angle of our tilt or our A-axis.
Okay.
Our A-axis, like most of them, the max they can do physically is 90 degrees. Now, on a flat table like this, you're not going to ever go to 90 degrees. I mean, if you are, you're clamping something up above. We can literally go up to plus or minus 120 degrees. But again, that's more for the 3D 5-axis where you're working with formed parts and things like that. And when we get into that, we have, you know, much more travel on our Z-axis and a lot more clearance underneath the beam. Those are just a few of the future type things as we bring the designs to market. So, but as far as the taperless side of it, I mean, you know, some of it is, you know, we've got enough information out in the industry as far as how much taper we have. I mean, a lot of times you're literally under 10 degrees when it comes to the taper. And then once you set that, you know, then the infinite C becomes, you know, pretty much part of that picture, so we can just roll around corners and stuff like that. You know, there's more coming in the future that it drives the reason for the infinite C-axis and the tangential following. That's when we get into more of the fancier cutting, some of the stuff we haven't really released yet. But that's coming very soon. I just started testing it last night, so we're getting closer by the day.
Right, and I'm sure you're having a blast doing it. And
yeah,
so,
well, it's
exactly.
It's good to get it out in the real, you know, in the real world. Like now, all of a sudden, you know, I've been hidden. I've been below the radar, so to speak, because nobody knows who I am. Well, other than the thousands of machines I've worked on over the years, there's that. But at the same time, within the industry, I've flown below the radar because everything was so specialized. Sure. You know, now trying to take that specialized stuff and bring it down to where the end users can make use of it, because, you know, 20 years ago the programming was a lot more difficult. Today we have a lot more access to things that make programming easier for us, and, you know, that's the area we're putting more effort into now. It's like, we know we can do it, now let's make it so the end users can work with it.
Sure, and speaking of, we can do it, there's this claim being thrown around that we can cut at any angle without limits. So what does that mean to you, and how can you tie that into the capabilities of this machine?
Well, it's basically what I was mentioning just a minute ago, with the being able to go past the 90 degrees. Like like at one point they always talked about, like, we'll rotate it to 180. Well, you can't, because 180 equaled 90 in the real world.
Okay.
Now we can go 90, 120. We can roll it all the way around. As far as where you're going to make use of it, on a flatbed machine like this, where we're just worrying about bevels and stuff like that, it's not going to be as critical to that end user as it is to somebody doing, say, titanium stamped parts that are mounted up on a fixture. Then that starts becoming a lot more important.
Right. And then so we've got this concept as well where you can use multiple lengths of nozzles. Are we confined to that? What are our capabilities when it comes to that?
Yeah, okay. With the currently with the heads that are on the market, because of the rotation and stuff like that, you're basically maintaining a focal point similar to a laser. They work off of a focal point type scenario in their 5-axis world, and the water jet heads that are on the market today basically follow that same thing. So all the nozzle tubes are a set length, fixed length, stuff like that, and the standoff is pretty much fixed. The idea of reaching inside of a hole to do something, it's not possible to do that, because you're going to run into the other components of the head. Where something like this, you can actually go down inside. Now you're limited a little bit by the mixing chamber, but there's ways around that as well, and we'll get into that more in the future. But at the same time, now you can actually go down inside. You can change the length of the down tube as well. We've gone all the way up to 2 inches and up to 12 inches. So the whole thing there becomes the pivot length from your tool tip up to the rotation of your A-axis, the center of rotation of your A-axis. And with that in place, then the kinematic, as long as you know what that number is, which is just a calibration of the length. Now with that in place, now the kinematics are built into the controller, so the XYZ motion as the rotaries move around, it all follows suit and maintains a tool point.